Assalamualaikum and a very good day to my fellow panel and audiences. Today I am Farus Najira binti Muhammad Spawi. My matriculation number is DE170016, going to present about my FYP or PSM project Sarjana Muda 1 progress. First and foremost, the research is about the hybridization of energy sources using dual input DC-DC converter. I am going to present starting from the Chapter 1, which is the introduction, following with Chapter 2, literature review, methodology for Chapter 3, preliminary test, which is Chapter 4, and finally Chapter 5, which is the conclusion of my overall progress for Project Sarjana Muda 1. So first of all, I am going to present the essence of this project, which is the background of study. So, the energy storage hybridization has been a very important and popular research topic nowadays, since it provides more feasible economic options and it improves the efficiency of the energy source itself. A hybrid energy system, or HES in short, which incorporating various energy sources into a single power system, are far more reliable as compared to a system that only incorporates one energy source. So, the hybridization of the various energy sources can be achieved by using a multiple input DC converter or multiple input converter, which is MICs, such as a dual input DC-DC converter. The dual input DC-DC converter provides a more compact and economic friendly system, since it reduces the number of components in the system, and it also provides a far more efficient DC power distribution. Next, I am going to present about the problem statement of this project, but before that, please watch this short video clip. As mentioned in the previous short clip, renewable energy sources has been a very important topic or subject in the research and development. One type of renewable energy source is fuel cell. Fuel cell has a high reliability and efficiency. However, due to a long starting time and slow dynamic response, a low differential power output must be controlled by an energy storage system or ESS, such as the battery. Batteries are typically used to store energy, saving power during starting, and thus boosting the peak power capacity. The objective of this project is to develop a simulation model of a dual input DC-DC buck converter for a fuel cell and battery system, and then to analyze the performance of the dual input DC-DC converter for the fuel cell and battery system. The scope of this project is that I am going to implement a fuel cell stack of proton exchange membrane or PMM with 45 VDC and 6 kW, and also a lithium-ion type batteries as the input of the system, and also a buck type DC-DC converter. Next, I am going to present about the literature review. I am going to talk about the DC-DC converter, multiple input DC-DC converter, energy sources, and finally the hybridization of energy storage system. So what is a DC-DC converter? It is an instrument or device that converts voltage. It consists of a buck type, boost type, or buck boost DC-DC converter. Concerning the multiple input DC-DC converter, it is a system that incorporates various energy sources into a single power system. It consists of a non-accelerated and accelerated multiple DC-DC converter. And for the energy sources, there are various types of energy sources such as the battery, fuel cell, ultracapacitor, and flywheel energy storage. So, in this research, context, I am going to implement the hybridization of fuel cell and battery only. And finally, as for the hybrid energy storage system, it is a system that incorporates different energy sources with the supplemental quantities of power capabilities. It has various applications such as the hybrid electric vehicles or HEVs. And as for the methodology, first I am going to design the simulation model of the dual input DC-DC converter by using a MATLAB Simulink. And then I am going to insert or implement the rating specification into the model and then run the simulation test. If the system operates in a buck mode, I am going to analyze the system performance in terms of the output voltage or current. For the preliminary test result, in order to analyze the performance of the dual input DC-DC converter or to prove a better performance in terms of the voltage by using a dual input DC-DC converter, I first did develop a single input converter by using the implementation of only fuel cell in the system. And then I developed the dual input DC-DC converter by using the hybridization of fuel cell and battery as the input. So the output result did prove that the dual input DC-DC converter does provide a better performance in terms of the output value, in which that the single input only provides a 23 voltage and the dual input DC-DC converter improved it to approximately 36 output voltage. And the dual input DC-DC converter does satisfy the buck mode operation, in which it reduces the input voltage value from 81 volt to 36 volt. And finally, to conclude, the simulation model of the dual input DC-DC converter was able to be developed by using a MATLAB Simulink. The hybridization of the fuel cell and battery are used as the system input. The hybridization of the fuel cell and battery does provide a better performance in terms of the output voltage as compared to the single input converter. The simulation model also does operate in a buck mode operation, and the full development of the system will then be discussed in the FYP or PSM Project Sarjana Muda 2. Thank you.